The last factor I want to talk about influencing natural climate or climate patterns is albedo. So albedo is the percentage of incoming solar energy that is reflected by the surface of the Earth. So let's draw this out. We have the sun, right? And we have the sun reflecting or radiating energy onto the Earth. And we have different things on the surface of the Earth. So one thing we might have on the surface of the Earth is some forest and grass type areas that I'm going to show here in green. And we could also have water. We know a lot of our surface of the Earth has water. And another factor we might have is things like snow and ice sheets. So I'm going to draw that kind of looking like a little bit like a mountain, but imagine a mountain covered in snow. You might have glaciers on it. And then the last factor I'm going to show here is our human-built environments, because that's important for considering albedo. So this is my city with smokestacks, right? And all of these things are going to reflect differently the solar radiation. And we've all experienced this with things like the clothes we wear. So today I'm wearing a dark shirt, and if I went outside, it would feel hotter than if I was here wearing a light shirt, because certain materials actually absorb solar radiation and trap it closer to a surface than other materials. So you might be able to guess that our lighter materials, such as the snow and the ice, actually reflect the most solar radiation back into space. So they have an albedo of up to potentially 80 to 90%. Okay? So that's a high reflectance that's going back into the atmosphere without staying trapped close to the Earth. Whereas at the lower end, our human-built environments, which is our cities here, might only have a 10 to 20% or 10 to 25% albedo, which means that they're absorbing a lot more of that solar radiation and capturing it close to the Earth. And of course, if you had a blacktop or asphalt surface, that might be as low as 5 to 10%. Which is going to be why when you walk on asphalt on a hot sunny day, you can feel that it's going to feel a lot hotter than if you're walking over in our grassland, which is going to be over closer to, let's say, 10 to 20% albedo, which is still quite a bit lower, note, than our ice and our water, which is going to depend a bit somewhere between 10 to 60%. So we have different land surface covers that are going to have different albedos. Now, one last factor that's important to consider is that as the land surface changes with climate, you're going to actually get climate change associated with changes in albedo. We're going to walk through this a little bit with our ice patterns. So I'm going to go all the way over here and think about our ice for a minute. Ice has very high albedo, right? So we're talking at 80 to 90% of solar radiation reflected back out into space without changing wavelength. Now, what happens when that ice melts? That ice might melt and become something else. Let's say that ice melts and becomes a grassland. We've gone from 90% reflectance to only 20% reflectance. We're going to get hotter. As that gets hotter, guess what it's going to do? It's going to melt more ice. And that's going to be what we call a positive feedback loop that's actually going to increase the temperature, which is some of the things that we're seeing right now at our poles. So that really explains the concept of albedo, and we're going to move into next about how all these factors come together in things that we consider climate change.